Okay, guys, we're going to discuss chapter 23 of the organic chemistry, which is about ammonia and amine. Ammonia is a compound that attached to three different hydrogen, right? Three different hydrogen, and also have the lone pair in it. Hopefully, you guys can see it. And how how do they get the primary? Where do they get this from? Like, what is primary amine? What is secondary amine? What is tertiary amine? How are we gonna do it? You just grab one hydrogen and put an L group on it. The L group can be simple, has methyl, and it can complex, has a chain of carbon attached to a bunch of things. So this is the primary amine. What about secondary? Secondary amine, we're just gonna do the same thing. Another hydrogen and replace it by an L group, which is secondary, right? What about tertiary amine? The tertiary amine is a nitrogen that attached to three different L groups. So this is the tertiary amine. 1, 2, 3. 3 L group. Tertiary. What about this one? A little exercise. 1, 2 L group. Secondary. A little exercise. 1 L group is primary. Let's get to a little fun stuff. Is this lone pair localized or delocalized? In this case, it is delocalized. That means it can move. Right? If you see a lone pair on an hydrogen or an oxygen is one step away from the double bond, that means it's delocalized. How can we make this localized? It's localized. So the lone pair is exactly at the atom that attached to the double bond. In this case, is localized, right? There's name for them, allylic lone pair, but we're not gonna go there because that might get confusing. You get ammonia from carboxylic acid. Let's try this. OH. So this one, in order to keep the OH off, we will have to replace it by something to put the nitrogen, because nitrogen not gonna react with the OH as far as I see. So if we treat it with LOCl2, this is gonna kick the OH. You will have something like that. But now if you have excess NH3, which is ammonia, it can result to something NH2, right? So with this one, if we don't want this, because we're gonna provide ammonia, not ketone and other thing. If we don't want this, how can we go from this one to the ammonia? Easy and simple. Lithium aluminum hydride and H2O, two different steps, gonna get you where you want to be. You're gonna get rid of the oxygen and just have a plain chain of carbon with the ammonia. From benzene ring. If we have benzene ring, we want to form ammonia. How can we do this? It's so simple. We've seen it in the previous chapter. If we treat it with HNO3 and H2SO4, what will happen in this case? You will have the benzene ring with the NO2. We don't want NO2. We need ammonia. Come on. So how can we go from ammonia, from NO2, the nitrate, to the ammonia? We have something waiting for us that can help us. If we have H2PT, remember from chapter 12, you're gonna give us ammonia. Alkylation of ammonia, how the term say it? Alkylation. We're gonna add alkyl group to the ammonia. So if we have ammonia with 3 H's, has can recall with the lone pair, and you have a ICH3 going there. So what can happen? You know, this one can use as a nucleophile. It's gonna attack anyhow the lone pair. By doing this, you're gonna kick this with the electron. So at the end of the day, you will have N H with a methyl. In this case, this will have a positive charge, right? And somehow a base, let's pretend we have OH floating around, the lone pair on the O gonna grab one of the hydrogen, and the electron will go to this one just to make nitrogen neutral. So you will have from this one, we have a nitrogen with H, and also with the methyl on the top and the lone pair. Right? Example, we have this one. What about if, okay, let's bring this up. Don't forget, we had nitrogen with a H, with a methyl, with another H, and with the lone pair, right? If we have another one of these, what can happen? You will have the lone pair, it's gonna grab another methyl group. So what would you get? We have nitrogen, methyl, H, and another H, right? With a positive charge. Somehow the base floating around gonna grab one of the hydrogen, right? Gonna grab one of the hydrogen. You will have nitrogen, methyl, and H. By doing this, the lone pair will kick off to this one. Now we're still gonna have another lone pair. What about if you have another one react to it? What would happen? Same thing. CH3. This one gonna attack this, kick this off, right? We have N methyl, this hydrogen, and the other metal that you just added, right? With the positive charge. Somehow again you will have a OH floating around, gonna deprotonate this one. The lone pair will go to this, and you'll have one methyl as the final product. What about if you do it over again? So just to save time, we're just gonna add one methyl, but in this case is gonna have a positive charge. That makes sense? Okay. We're gonna learn the reaction with the azide. And this compound called azide, this have a negative charge, positive charge, negative charge. Hopefully you guys can see it, because I believe I have a clear earlier on this one. So what's gonna happen if we react this one with our X? This one, the X group is an alide. It can be bromide, chloride, any alide. So what's gonna happen? Don't forget, this one have two lone pair, doesn't have any lone pair. This one have two lone pairs. That's what make them negative. So the negative charge, the lone pair gonna attack this R group. The carbon in the R group is gonna kick this off. So you will have the R with N double bond, N. Again, this one have a negative charge, positive charge. This one is gonna be neutral, right? While it's neutral, don't forget, you remember Al, H, and H. This is gonna grab one of the hydrogen from lithium aluminum hydride. So you will have at the same time this gonna kick off to this one just to make it neutral. So from this step you're gonna have our group with N, with the H, with N double bond N. Again, this one is negative, this one is neutral. What can happen next? Don't forget, you have two lone pair on this one. This lone pair can go back while it go back, this is gonna have a positive charge. Instead of having a positive charge, you're gonna kick this off. Right? So while it kicked it off, you're gonna have R and H, right? With a negative charge, and also you have, N2, 2N, which is N, triple bond, N. These are the same thing. Does that make sense? Hopefully you guys understand this. Reaction they call a Gabriel synthesis. Gabriel synthesis is a pretty much benzene that have two ketone with an N attached to an H. This one is a ketone. All of these coordinates are carbon. Now you've been know this from since Hubble 1. Okay. If you reacted with KOH, right? The OH group, this is positive, this is negative. The OH group will get this one. The lone pair will grab this hydrogen, and this gonna go there. So you have this gonna result to 1, 2. This is my benzene. This is still the ketone. Still N, but without the H, now we're gonna have a negative charge, because when it had one lone pair before, when this lone pair go back to it, it's gonna have another lone pair, which is gonna make it negative. While it's negative, it will really attract. It can attack anything, which make it a really good nucleophile. So again, the lone pair on this one gonna attack this carbon and gonna kick this off eventually. So you will have this benzene ring thing with the ketone, with the N. This is an ethyl, two carbon, 1, 2 carbon, and this one you still have the lone pair in it, right? But with this, if you treat this one with a junium H3O junium, what can happen? Is it just gonna cleave this bond? Let me do it in a different color for you. You're gonna cleave this bond just to liberate this one. So you will have 1, 2, 3, 4, 5 benzene, carboxylic acid, with the OH, and you're just gonna have a nitrogen with an ethyl, with an H, with an H.